let's move now to pipes. So this is the last part for today, and we're going to see an example of a specific way in which the process can communicate. As we will see now, we have two types of pipes, ordinary and named ones. Ordinary pipes are communication channels that can only be accessed by the process that creates them and the child. Named pipes, on the other hand, can be used without, by two processes that do not need to have a parent-child relationship. So the ordinary pipes, in other words, are the, let's say, standard producer-consumer queue. They are unidirectional, and in fact, before two processes can use them, a parent and a child, they need to specify who is going to be the writer and who is going to be the reader. We're going to see this in a piece of code in the next slides. In Windows, these are called anonymous pipes. Named pipes, as I said before, they are more powerful in the sense that they can be used by two processes, even if these two processes are not parent and child. Actually, they can be used by even more than two processes. They allow for bidirectional communication, and well, notice that you can also create two ordinary pipes and use them in different direction between the parent and the child, so you can still achieve bidirectional communication. But named pipes, one named pipe allows for bidirectional communication, and also in this case you can find them both in Unix systems and Windows systems. In fact, you might have been using pipes even if you didn't really know that, but if you run this command, this thing here, it's a pipe. It's what I just said, and what you basically do when you run this command is to tell the operating system that you actually want to run two different processes, one that lists the file of a folder and one that searches inside the text for specific patterns, but you want to create them with a pipe in between and actually send all the output of the first as the input of the second. Okay, so if you just run the list command, you get a list of what you have inside a certain folder. Okay, if you put a pipe and then another process, with this pipe you are feeding the output of the first command as input of the second command, and in this case you're going to keep only the entries that have this pattern on the month of April. So let's look at an example now. And by the way, if the example with fork is not clear, go back and try it yourself, because this builds on that example. We have three macros here. We create the buffer size 25, and we put two numbers, 0 and 1, for the read end and the write end. We are going to use this with the pipe. So we create an array of two arrays of characters, write and read message. And in the write message, we store greetings. We create a process ID, and we create an array with two integers. This is the file descriptor, it's the ID of the pipe. Now, we call pipe to say to the operating system that we want a communication channel that will be used between a parent and a child process. Now, this file descriptor here will store, once we call pipe, the values of the two ends, the write and the read end of the pipe. This check here is, so this if statement is run if there is a problem when we run pipe, otherwise this is just skipped, but still you call pipe and you store in the file descriptor the write and the read end, and then we call fork. This is the important point. Fork, as we said, is going to create a copy of the process. Now, you create a copy of the process, so everything you have done until you have called fork will be reflected also in the copy, which means the copy will have also a file descriptor, and the values of this file descriptor will be the ones that have been stored when the original process called pipe. This is why you are calling pipe before you call fork. If you were to call pipe after fork, the two processes each would create a different pipe, and they would have different file descriptors. After that, it's similar to what we saw before. We check if there was a problem with fork, and if that is not the case, then we run different code depending on whether we are the parent or the child process. The parent process closes the read end and writes to the write end the message, and then it closes also the write end, so basically close both ends of the pipe. And the child process does the opposite. It closes the write end, it reads the read end, prints to screen what it just read, which is greeties in this case, and then it closes the read end of the pipe.